Good morning, fourth grade friends, and welcome to multiplying fractions. So today we're going to be working on lesson 23. We're only going to be doing a couple pages from this lesson, and then on Wednesday we will jump into lesson 24 since it's still talking about fraction multiplication, okay? So for today we're going to be doing a couple different pages. We're going to be doing pages 491, 495, and 496, and then on your own you're going to be doing page 498. So first we're going to start off with page 491, and we're going to look at number 1. So it says, look at the model and write an addition equation to add the 1/3. So each of these are 1/3. So I'm just going to label each of them 1/3, 1/3, 1/3, and 1/3. I'm just going to add them. So I'm going to add plus signs in between, and we're going to add them together. So our denominator is going to stay. And then we have 1 plus 1 plus 1 plus 1, or 1, 2, 3, 4. So we have 4 thirds, and we know we can change that, right? So if we have one model here and one model here divided up into thirds, and we shade in 4 of them, that's equivalent to 1 and 1/3. So 4 thirds is equal to 1 and 1/3. Okay, and this is just more practice with our mixed numbers and changing them from an improper fraction, okay? So this is the adding, and as we know, multiplication is just repeated addition. So now we can use multiplication with fractions to show repeated addition of fractions, just as you do with whole numbers. Complete the sentence and equation below. So here we have 1, 2, 3, 4 copies of 1/3, and we know that that's equal to 4 thirds, right? Sorry, I'm writing a little big here. So we could say 4 times 1/3 is 4 thirds, okay? And when we multiply fractions, we think of it like the 4 is over a 1, right? Because 4 over 1 is just like saying 4. So 4 over 1 times 1/3. 4 times 1 is 4. 3 times 1 is 3, right? So this is just proof as to why it works. So this is going to be our focus for today and the rest of this week and a little bit into next week, just multiplying fractions. So if you don't have any questions on page 491, let's jump on to 495. We're going to go over a couple more practice problems together, and then you'll be trying out page 498 on your own, okay? So, number 1 on page 495 says, draw an area model to show 3 times 2/5, then write the product. So an area model, we can just make a picture to show 2/5, and we need 3 of them, right? Because we're multiplying by 3. So we're going to draw 3 models, because it's 3 times, and then it's 2/5. So that means each of our models have to be divided up in 2/5. So 1, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So now each of these are divided up in 2/5, and we're going to shade 2 out of each of them. 1, 2, 1, 2, 1, 2. So we have 2/5, 2/5, and 2/5. Now, just like regular multiplication and addition, multiplication is just repeated addition. So we could add these, right? And we get 2 plus 2 plus 2, which is 6 over 5. So when we multiply, this is what we should be getting, okay? So we have 3 times 2/5. And remember, you can always just put the 3 over a 1 because it is a whole number. So 3 over 1 is just like saying 3. And then we just multiply across. 3 times 2 is 6. 1 times 5 is 5. So 3 times 2/5 is 6/5. Now, you don't have to do the 3 over 1. You can just do 3 times 2 over 5. And then just know it's 3 times 2 is 6. We keep the denominator, okay? And that's only with multiplying by a whole number, so that's why the denominator stays the same. Now we're going to do the same idea here, so I'm going to set this one up, and then we'll see how we do, okay? So we're going to have to do 6 of them this time for our area model. So we're going to still divide it up in 2/5. Again, I know these aren't even. I am not an artist, nor do I try to be one. It's just for a matter of example, okay? So we have 1, 1, 1, 1, 1, 1. So this is 1/5. And I say we always try adding just to check our work and know we're getting the right answer. And I feel like right now we feel more confident with adding, so it's a good way to check ourselves. So denominator is gonna stay the same as always, right? And then 1, 2, 3, 4, 5, 6 ones is 6. So we should be getting 6/5 again. So let's try it out. If we do 6/1 times 1/5, 6 times 1 is 6, 5 times 1 is 5. Could also just do 6 times 1/5, and then we still get 6/5. 6 times 1 is 6, 5 times nothing is 5. So 6 times 1/5 is also 6/5, okay? So if you have any questions at all, sorry, I'm trying to make this a little bit easier to see. If you have any questions at all on either one or two, please pause here and let me know. Or if you need to pause to write any of this down. If not, we're gonna jump on along to page 496. So this is just using the number line to help us. So number 3 says fill in the blanks on the number line to show 4 times 3/5. So if we have 3/5 here and we double it, this is going to be 6/5. Okay? And then, well, not double it, sorry, multiply by 3, right? So it should be counting by 3s because it's 4 times 3/5. So each of these, the denominator is always going to be 5, but our numerators are going to change by times 3, or be multiples of 3. So we have 3, 6, 9, and then if we're counting by 3s, the next one would be 12, right? So we have 1, 2, 3 jumps, we get to 6. 3 more jumps, we get to 9. 3 more jumps, we get to 12. And then if we jumped 3 more times, we would get to 3. And remember, 3 could also be shown as 15/5, right? So if we kept going to the 3, it'd be 12, 13, 14, 15. 15 divided by 5 is 3. So these are equivalent, okay? So just be mindful of that as we work through these number lines. That's where it gets a little tricky with the equivalent fractions. But then we can just say 4 times 3/5 is 12/5. Now, if the number line is a little crazy to you, you could also just say 4 times 3/5. 4 times 3 is 12. Denominator is 5, just to check your work, okay? And now this one, they want us to label the number line to show 6 times 2/10. So instead of going up by 3/5, we're going to go up by 2/10. So if we look, we have 1, 2 jumps, so this would be 2/10. 2 more jumps, so 1, 2 would be 4/10. 2 more jumps would be 6/10. So our numerator is just counting by 2s. 2 more would be 8/10. And then this would be 10/10, which is also just equal to 1. And then 2 more would be 12/10. So we're just still counting by 2s. So 6 times 2 is 12. Keep the denominator, or it's also just 12/10. So this one you have to make sure you're counting up and keeping track of your dash marks. So it's just a matter of what feels the best to you, okay? So we have number 5. How are the area models and number line models alike and different in showing fraction multiplication? Well, they're alike because they both show the area being divided, right? So we can say the models are alike because they are divided into equal parts. To show fractions. They also can both be shown using repeated addition they are different. Because the number line has labels for equal parts. Sorry friends, I'm kind of squishing. That's okay. So that is your answer to number 5. So if you need to pause to write that down, feel free. And then number 6, choose any model, so either the number line or you can use the area models, right, to show 3 times 2/4. And I want you to show me on the Google Meet, okay? And you will get points for today's class by showing me. So make sure you do. And show me how you solved it, and tell me your final product for 3 times 2/4, okay? And then once you do that, you can jump into page 498. I'm in the Meet if you need anything. See you soon.